this is chapter 1, section 2. Now we are going to be talking more about functions and limits. Alright, so let's see what we have here. Okay, mathematical modeling is, so this section actually is talking about special function, essential functions, or maybe we should say popular functions. We are going to just briefly tell you about that. And here it talks about the modeling as well. What we do is, I'm going to talk about these essential functions, and we use those essential functions, popular functions that are well known, to model the real life problems. So in this picture actually it says, as engineers you should know that you're going to start learning these things. So for example, you're going to be given a real world problem, and then what you do is you take it as an engineer, you formulate it in terms of math, and you come up with a mathematical model. And then since you have a mathematical model in front of you, you want to solve it. You solve it, you got some conclusions, we call them mathematical conclusions. And then you look at these conclusions and then you want to interpret them, you want to say something about those results. Okay, and then you want to say something about the real world predictions. You say, because of this model, because of this solution, we expect that this is going to be, this is what's going to be happening in the future or something. Okay, so this is roughly the idea of mathematical modeling, and as engineers you're going to be doing this all the time. All right, so we have linear functions like the line. Line is a linear function, and we use this line equation to come up with linear models. Okay, so what's the linear function is? It is mx plus b. Everybody knows that, right? M is the slope, b is the y-intercept of this line. Okay, for example, this is a line. Okay, the slope is 3, and it passes through -2 here. Do you see that? This is the y-intercept. And if you want to draw the graph of this line, what you could do is you can just list the x values and then find the corresponding f of x values and plot these points on the graph and combine them. But this is a long way to do. You just need 2 points actually, and combine the 2 points, and that should be enough. Alright. Okay, so this is an example about a modeling. I'm going to just skip that. Okay, so we have polynomials. Next complex thing after linear functions is polynomials. We use them a lot. Okay, they are used everywhere. As engineers, you're going to see it quite often. This is p of x is equal to an x to the n plus an minus 1 x to the n minus 1 plus a2 x squared plus a1x plus a0. So here we have the x terms. Okay, we have the coefficients to these x terms. This polynomial has a degree. The degree is the power of x, the biggest power of x in here. So here it seems n is the biggest power, right? So here n is the degree of the polynomial. Of course, we assume here the coefficient of x to the n is not 0, because if it is an is 0, then the degree is not going to be n, it's going to be less than n. All right? So, okay. So after linear functions, so linear function which is mx plus b is a polynomial too, and it's a polynomial of degree 1. And we have quadratic functions, which means polynomials of degree 2, ax squared plus bx plus c. You've seen this, you have used all these things like since middle school, right? You are familiar with all of these guys. Okay, so therefore but maybe the drawing the graphs is difficult for you. So the simplest one is y is equal to, I can't see the example here actually, maybe I should just give me a little bit, I'm gonna try to For some reason this is do you understand the problem? I'm trying to move this away. There should be a way to hide this, but it doesn't allow me to hide it. Anyways, so this is a polynomial looking upwards, and this is a polynomial looking downwards, okay? The formulation is given here. So it's the x squared has a negative coefficient, so it is going down. It's looking downwards. But whenever x squared has a positive coefficient, then it's looking upward. So depending on a less than 0 or bigger than 0, the parabola opens up or down, okay? A is bigger than 0, then it's opening upward like in here. A is less than 0, it's going to be opening downward like this here, alright? Okay. Alright, a polynomial of degree 3 is of the form this. We know the ax cubed plus bx squared plus cx plus d. Okay. Alright, so we call them cubic function because the degree is 3 here. Okay, this is a polynomial again, polynomial of degree 3, and it's called a cubic function. And usually it's going to be like this wave thing. Do you see that? Okay. So this one is actually order 5 should be, okay, this is bigger than order 3. Order 3, I mean, this order 3 is going to look like wave like this, okay? Alright, so next, I'm going to skip that. We have power functions. Power functions are, for example, x to the a, x to the a. For example, f of x is equal to x to the n. So this is a polynomial too, actually, right? But we call it power function because we want to analyze them separately, because they are special, because we use them all the time, and we give some our examples from power functions. So we need to focus on this a little bit more. Okay, so these type of functions are f of x is equal to x to the a, where a is a constant. Okay, so depending on a values, this function is going to look different. Okay, the graph is going to be looking different. For example, let's say if a is all integer, positive integer, like for example, f of x is equal to x, f of x is equal to x squared, f of x is equal to x cubed, f of x is equal to x to the 4, f of x is equal to x to the 5. So these are power functions, okay? Let's see the graphs of those, okay? X squared is a parabola, we know, okay? So y is equal to x, for example, it's a line passing through the origin. Y is equal to x squared, we draw this, it is looking like this, opening upwards and going through the origin, symmetric with respect to the y-axis. We talked about that. Because it's an even function, right? You remember? Okay. So this is actually symmetric with respect to the origin. And this is an odd function. This is an even function. This is an odd function because symmetric with respect to the origin, x cubed. X to the 4, it's symmetric with respect to the y-axis. It is even function again. X to the 5, as you see, it is symmetric with respect to the origin. It's an odd function. This is even, this is odd. Okay? You understand? Alright, so these are special when it comes to the power a being positive integers. So what happens if it's not a positive integer? Alright, so these are different versions of, see, it's comparing whenever we have like second power, fourth power, sixth power, when it's even, look at them. I mean, they don't, even if they look all similar, they are not the same. See, there are some differences here. And for example, if you have the odd powers, x cubed, x to the 5th, they look similar, the graphs look similar, but actually they are not exactly the same graph. So that's in these pictures, they are explaining it to you, that. Okay, so what happens if the power is just 1 over n? Okay, where n is a positive integer. Now it's going to be looking like this. F of x is x to the 1 over n. This is nth root of x. This is a root function. We call it root function. Whenever we have the powers in the form of 1 over n, we got root functions. The basic one is square root of x. Square root of x has this picture, and I want you to keep this in mind. Like, remember the square root of x, okay? This is very important. Let's analyze this square root of x a little bit. So what is the domain of this function? What is the range of this function? The domain of this function is 0 to x. You don't have any picture of it for the negative values. The reason is because of the square root. Inside the square root, you cannot have a negative number. So therefore, we don't have any picture on the left side, okay, for x negative values. Alright, so, and the domain is all 0 to infinity. How about the range? The range, as you see in the picture, 0 to infinity as well. So the domain and the range are the same set. Sometimes is the same set, sometimes this happens. Alright? Next, let's look at cube root of x. Cube root of x is also, I want you to know this as well. Okay? Square root of x, you should know the graph. Cube root of x, you should know the graph. Keep this in mind. Just draw by your hands. You're gonna see. So it is like this. It is similar to what? X cubed, but it's like it is converted. Like it is, if you take the symmetry with respect to the y is equal to x, you get this cube root of x. So it is similar to the x cubed, but it is looking the other way around. Okay? So you can remember it like that. The third part is when the power is just -1. We call it reciprocal function. The name is just reciprocal function. It's the reciprocal of x, 1 over x. So why do we want to know that? Because it's a special function. It is the basic function of such special functions, okay? That's why we call them rational functions. You're going to see it later on. It is the simplest of them all. Therefore, we want to introduce you here. So 1 over x is special, and the graph is going to be like made up of two pieces like that. We have one piece here and the other piece here. And I want you to memorize this picture as well. Okay, this is very important. And rational functions. Rational functions are polynomial over polynomial. Okay? It's the ratio of two polynomials. Okay. So, for example, 1 over x is a rational function. On top, the polynomial is 1. In the bottom, it's the polynomial is x. As you see, the domain of this 1 over x, think about the domain of 1 over x. The domain of 1 over x is everything except 0, because at 0, the denominator becomes undefined. Alright, so rational functions are the functions where the denominator is not 0. Okay? The domain is going to be everything except that the denominator is not 0. For example, let's consider this example. This is a polynomial over polynomial. So if somebody asks us about the domain of this function, we are going to look at the denominator, x squared minus 4, and we are going to look at x values that's going to make the denominator 0. X values that makes the denominator 0 is 2 and minus 2. So these are bad points. We just want to get rid of them. So we are going to say the domain is everything except -2 and +2. Okay? This is the graph of it. I don't want you to memorize that. In the future, I'm going to tell you how to draw this graph. So forget it right now. I mean, you don't have to memorize it. But I want you to just pay attention that the bad points, x is equal to 2 and x is equal to -2, they are called asymptotes of this graph. Okay? So we will talk about these guys as well in the future. Okay. So algebraic functions are the ones that are the rest. I'm not going to go into details. Other difficult functions you can consider algebraic functions. And we have trigonometric functions. Trigonometric functions you guys learned from in middle school, high school, sine x, cosine x, these are the trigonometric functions. So sine of x and cosine of x, these are called wave functions. Look at the waves. They are like waves, perfect waves, okay? And you can consider, for example, cosine x is a shifted sine x. If you shift the sine function, the graph of sine to the left, okay, by pi over 2, you're going to get cosine. So cosine x is actually shifted sine x graph, okay? All right. This is just for you to remember, okay? All right. And we all know from middle school that sine of x is between -1 and 1. It cannot be bigger than 1. It cannot be bigger than less than -1. Similarly, this is the same for cosine. Okay, these are that special functions. Okay, so the zeros of sine of x are where x is n pi. So sine x is going to be 0 at 0, pi, and then 2 pi, 3 pi, 4 pi, 5 pi. Similarly, -pi, -2 pi, -3 pi, etc. Sine x will be 0 at those points. How about tangent x? Tangent x is actually sine over cosine. So the graph is going to be looking like that. So we have a one wave here. Look at this. We call this as one wave. So if you repeat this one wave to the right and to the left every pi units, then you're going to get this picture, the whole picture. So this one wave looks like x cubed, right? It's very similar, but it's not the same. Okay, so this is the tangent x. Exponential functions. Exponential functions are the functions, different functions, like it is a base and power. The base is a number, power is an x now. So it is the opposite of power functions. Power functions, the base is x and the power is a number. For exponential functions, the base is a number, the power is an x. For example, we have two examples here. Depending on the base, here the base is b. If the base b is bigger than 1, we have this type of picture. If the base b is less than 1, then the picture is going to be going down. So whenever b is bigger than 1, it's an increasing function. Whenever b is less than 1, it's a decreasing function. Okay? So we have this for exponential functions. All right. And we have last example, logarithmic functions. Okay? All right. For logarithmic functions, what do we have? Let's see. Logarithmic functions, you can consider log functions as inverse of exponential functions. And see, the graphs are similar, but it's the other way around. So exponential function is going up like this, but log x is going down like this. So it is kind of symmetric with respect to the y is equal to x-axis. So they are inverses of each other, logarithmic functions and exponential functions. So log x, they are all going through the 1, because log 1, regardless of the base, it's going to be all 0. Okay. And classify the following functions as one of the types functions that we have discussed. So this is, the base is a number, the power is an x, so this is an exponential function. G, the base is an x, the power is a number, this is a power function. This is an algebraic function, not a rational function, because for a rational function it has to be polynomial over polynomial. This is not a polynomial. Okay, this is an algebraic function, and this is a polynomial. All right. These are the answers. Okay. All right. That is it. And give me 1 sec. I'm gonna change it to the other PowerPoint slide. Give me just a couple of minutes.